Okay. Parallel. What does it mean for something to be parallel to the xy plane? A vector is parallel to the xy plane when what is true? What does that mean? What does it mean if something's parallel? Umi.
It means there's no change in height, so FZ is.
There's no change in height?
There's no change in.
Oh, going up and when you say height, you mean up and down. Okay, so you have the plane right there. It's not bad. Could have been better here. We have x, we have y, and we have z. So it means there's the z. All it means is any vector. It could be something like this: a, comma b, comma what? A vector is parallel to the xy plane. You just said it out loud, so it doesn't have what?
It doesn't have any changes in z.
So what does that third value have to be?
So
what?
0.
0, exactly. Any vector AB0 will be parallel to the xy plane, correct?
Yeah.
Do you agree with that?
Yeah.
Yeah. It could be 5, 6, 0, right? It could be parallel to the xy plane. Are we okay with that so far? To be 0. So what should we find then? F what? FZ, exactly. So let's find FZ of XYZ. What's that going to be? So let's just write this out. It's x squared minus y times z to the what? -2. Are you with me so far? I just rewrote this equation. So what's FZ going to be? 2y z to the -3. So that's 2y over what? Z cubed. What's the only way for this to be 0? When what? It's when y equals 0 and so z doesn't equal 0 or we have a problem, right? So it's asking us, it says, find all of the points on S where the normal vector is parallel to the xy plane. I could be totally off with this method. I think I'm okay with this method. So we think it's when y is equal to 0. Where do we take that y equals 0? What do we do with that? If we want to find all points on this surface where that's true, what do we do with that fact that y equals 0? Where do we put that? It's right there in the middle of the screen.
Into the x squared.
Into the what? What? Okay.
X squared minus yz.
Exactly. So we know that our equation fxyz, what is it? Is what? X squared minus yz to the -2. We're looking for all the points when y is equal to 0. So where do we take that y equals 0? Where do we put it? Into what? Into the equation, yeah. We're looking for all the points where this is true, so let's try to find them, right? We know that y has to be 0 because that's the only way for it to be 0. So what does that tell us? That's true when f of x, y, z is equal to what? X squared. Do we have any more information to throw at this problem? I don't think so. I think that is the answer. What did the book say? Nothing that really changed. There's two starting variables, exactly. Z still has an input of x and y, but then x and y are both written in terms of u and v. So theoretically, I could ask you for delta z, delta u, or delta z, delta v, and you would have to come up with 2 different paths for each one. You just have to keep track of those things. What you end up seeing is when you write it out, it looks all intimidating like that, but now that you've seen tree diagrams, is that not that bad? It's not that bad. It is not that bad. At least I think it's not that bad. Okay, so get back to the board. Here's example 4. Draw me a pretty, pretty tree and find me the answers.